As AI becomes central to decision-making, one question remains: can you trust it to stay on course? Raids is an advanced AI safety monitoring platform that detects and alerts rogue behavior in real time. It continuously learns your AI system's normal behavior, establishes baselines, and flags deviations before they escalate into failures, bias, or regulatory exposure. Whether you're running large language models, LLMs, financial engines, or healthcare AI, Raids provides the visibility and control you need to deploy AI safely and responsibly. From finance to healthcare and beyond, Raids is becoming the trusted standard for proactive AI oversight. Raids gives you the confidence to scale AI without compromising on safety.
Hello, everyone. I'm here with a presentation of the Raids tool, a system capable of monitoring AI for rogue behavior. The very first thing we're going to do is to sign up in order to create an account. So you provide details for a company and provide your email and password as credentials. And create our account. We're going to log in into the system, and we're going to be presented with this screen on our first time login, where certain key terms of the Raids tool are presented. The first one of them is, what's baseline? Raids aims to detect rogue activity in your AI system by comparing it to its normal behavior. And in order to understand what this normal behavior should look like, it ingests a baseline of previous interactions of users with your system or training data. Now, in order to connect with your system, Raids uses a simple API system, and using an API key, it's possible to forward all live data to Raids for evaluation. Now, two very specific terms to Raids is a Raids model, a deep learning model that has been trained on your data in order to identify rogue activity, and the monitored AI system, which is your system, that we're monitoring with Raids. Let's start with setting up our first model. Here we're going to select an LLM model type, and we're going to name this model, so let's call it Demo Model, and create it. Raids generates the API key that we're going to be using in order to connect, so we're going to store this, and Raids needs us to upload a baseline file containing past user interaction with your system, or even the training data for best performance. So we are going to upload that. Upload baseline here. As soon as this is uploaded, we can ask Raids to start learning from this baseline. So we're going to calculate this baseline, and while this runs in the background, we are prompted to check out the dashboard that Raids uses in order to allow us to view the behavior of our AI system. We have a full tutorial here, pointing to the various aspects that can be seen in the dashboard. We're going to be skipping this for now, and we're going to go straight into the monitored AI system that we just created. So, we're going to click on the cogwheel, we're going to view. Again, here we have a full tutorial letting you slowly learn all the systems that are in place here. And, of course, we can always go to settings to customize our experience, or even go to the assistance menu for any troubleshooting or any issues that might come up. So this baseline has already been consumed, has already been ingested by the system. But we also have the additional feature here of using a live baseline evaluation. Essentially, Raids is able to not only learn from past interactions with the monitored AI system, but it can always keep using new future interactions in order to at all times improve itself. We are going to leave this on off for now, but we are going to create our first Raids model. So we're clicking here, and here we're going to present it with different options. We can either choose a single Raids model, which is a lightweight option. It doesn't consume too many resources, and it lets us quickly know whether our data exhibits any raw behavior or not. Or we can choose the ensemble, which is an ensemble of either different architectures of models or different initializations of those models. Let's break down the different ensemble options a little further. The architecture ensemble combines different model architectures to better capture complex patterns, whereas the initialization ensemble trains the same model from different starting points for more reliable results. So let's try both. Let's create an architecture ensemble. So Raids is now going to start training this ensemble. And while this is going on, we can talk about the dashboard. So we can go back here to the dashboard. And here we're going to be presented with an overview of the activity of the monitored AI system. The first kind of monitoring has to do with a bar chart that is going to appear here as soon as we have active models and we can view normal and rogue samples in different time periods. We can see for how long RAIDS has been monitoring our system. We can see how many rogue detections we had up to today, and we can see an average as well. Of course, we're providing different filters here for a customizable experience. And all these options have tooltips in order to always let us know of what they're doing. At the same time, we have an action log here to the right, and all critical events that are detected by RAIDS are going to appear here as notifications. And the user can always click on them and see what's going on. But the training should be over by now, so let's go back to our system. We can see that this training is still going on, but we can wait for a short while for this to be ready. Our model is now ready, and we can get a short tutorial of detection methods. Let's see those in practice. Here we can click on the cog, and we have two options. The first one has to do with selecting the version of the model. Now, since RAIDS incorporates mechanisms that allow the system to continuously improve on new data and on new human feedback, previously trained models are always stored. And in case we notice that the previous version performs better than our current one, we can always roll back to it. But what we are more interested in right now is selecting methods. We are presented with 4 different options. Now, since ensembles of models actually are made up of many different models, we can choose how we are going to use their output. So, we can either let its model vote, or we can let its model come up with their output and average over all those outputs. We can use the aggressive method, where all models generate an output, but we are trying to aggressively look for rogue behavior. So the system is more sensitive to any deviations from the baseline. And on the flip side, we can use a conservative approach, where the system essentially holds back and only looks for big deviations from the baseline. Let's choose the voting majority for now. We can either activate this model to be monitoring for rogue behavior, or we can create more models. So let's say, for example, we want to create a single model. Again, this is going to be created and trained, much like the previous creation of the ensemble model. And here in the ensemble, while the single model is training, we can see that the chosen method for this model is the voting majority. And the baseline file that this model has been trained on is this df clean CSV file. This is important because we can always upload more baseline files, and we can train models on different baselines. So let's activate one of those 2 models. Let's activate the single model. This model is now standing by, and any evaluation data that comes its way is going to be monitored, and it's going to return an output. So let's try this in action. We have an LLM deployed here, and we're going to ask a question from this LLM. Let's say, how can I improve my fitness? A very important thing we have to do here is to use this API key. So we're going to use the API key generated for the specific monitored AI system. We're going to connect the 2, and we're going to send this prompt. Now, this prompt is being sent to a DeepSec model, the 1.5 billion parameters version, and soon this LLM is going to think about its response and generate an actual response. Now, this response here is going to be forwarded to RAIDS. RAIDS is going to evaluate it, comparing it to the baseline. So, if we go back to the dashboard, we can see that we have our very first evaluation. We can see that the single model trained on the df clean baseline file has had one evaluation on one sample, and it found it to be normal. But we can drill down in this one. We can go to Analytics, and here we can see that this sample generated at this specific timestamp has been found normal. You will notice here that this bar chart references a severity value. Severity is a metric we have developed for RAIDS that allows us to see how severe the rogue behavior of each given sample is. It's a metric that ranges from -infinity to 1, and all values above 0, all positive values, are going to be found to be rogue. We can see here that the severity of this particular sample in this data table view is -13, which classifies it as a very normal sample. This classification was done with single model type, which does not have any method because it's not an ensemble. At the same time, we can see a loss value, which is 0.0002. And we can see here that essentially our system was able to very effectively recognize the sample as being something close to the baseline and had no trouble at all at classifying it as normal. Now we can drill down even further and click on this sample and see all the metrics for it. First, we can see what our raw data looks like. This is the prompt that we sent to our LLM. This is the response that we got. And this is how long it took for the system to return this response. We can see that the severity, as we said, it is very normal. It's in the minus levels. And here we can see all the indicator features that we're using in order to investigate its sample. We can see their actual values numerically, and we can see a series of bars where its vertical line shows what the mean looks like according to our baseline, and with a dot, the actual value of this particular sample. So we can see that for all of these indicator values, our sample is very close to the means. Now, finally, we can provide some feedback to RAIDS. We can say that, yeah, this response looks pretty normal. So we can agree with RAIDS, and we can even provide some textual feedback and submit this feedback for RAIDS so that we can continuously improve its performance. Now, if we reach a point where RAIDS has made a few mistakes, and we have gathered some samples where the user feedback is in disagreement with its response, then what happens is an automatic retraining is triggered for RAIDS. So these samples are forwarded to our models, and the models get to know them better, and they avoid making such mistakes in the future, or mistakes similar to these ones. As a final point, we can go to Settings, and we can go to System. Now we have ways of alerting the users of samples that deviate from normal activity. Of course, we might not want all samples to be forwarded, and only those that are really severe. So we can choose the threshold over which we're going to be notified. Save this, and let the system know how often we want to receive a mail showing us those notifications. Of course, all samples are still going to be evaluated and are going to be added to the dashboard, but they may change. Emails will only notify us about the very important ones. So, this has been a presentation of what RAIDS looks like, how we're able to monitor our AI system, and what the metrics that we're using look like. Thank you very much.
RAIDS empowers your team to monitor AI behavior in real time, detect anomalies as they emerge, and act with confidence before systems drift, fail, or cause harm. With seamless integration, domain-specific insights, and enterprise-grade reliability, RAIDS helps you stay ahead of risk, meet compliance standards, and build trust across every AI deployment. We're now partnering with forward-thinking teams through our pilot program, offering early access and hands-on support. To learn more, visit www.raidsai.ai or scan the QR code to book your personalized demo. RAIDS, because safe AI is smart business.